Part B is called magnitude and unit vector. And we already know that magnitude means length of vector. Unit vector means a vector of length 1 unit. So if we have vector v, we can write unit vector v as v hat. So this is unit vector of vector v. So say for example, I have vector m, therefore the unit vector of this vector is m hat. So let's try coordinate P, A, B, C. So we can write the vector OP as P, and in calculation we can use this bracket to write our vector. However, your final answer should always be in this form where we have the unit vector I, J, and K. And the magnitude is the modulus of OP, or the magnitude of OP, or the magnitude of P, and it is square root of A square plus B square plus C square. And therefore, the unit vector is P hat, where it is actually the vector P divided by the magnitude of the vector. So just write down vector P is AI plus BJ plus CK, and it is divided by the vector P, which is this one. And to write the final answer, it should always be written in this form: something I plus something J plus something K. So you cannot leave your answer like this. You must leave your answer in I, J, and K only. So you can do the same for the coordinate S, D, E, F. Just use the same concept as the one we did here for this part. Let's do example 1, question 1. So PQRS is a parallelogram with vector PQ is vector M and vector PS is vector N. So here is our parallelogram. So don't forget, parallelogram means that these two sides should be parallel and these two sides should be parallel. So you can label the vertices PQRS either in clockwise rotation or anti-clockwise rotation. You must follow either one of these only. You cannot just write PQRS wherever you want. No, you cannot do that. You must follow either clockwise or anti-clockwise. So say for example, I want to do it like this. So we know that PQ is M. PQ is vector M. And PS is N. PS is vector N. Next, we have T is the midpoint of SR. So SR is here, and T should be the midpoint so that the distance between ST and TR is the same. So since PQRS is a parallelogram, this means that if this is vector M, therefore this is also vector M. So SR is also vector M. And if PS is vector N, therefore QR is also vector N. So we need to express these vectors in terms of vector M and N. So first is vector SQ. So SQ is here. And to get this vector, by using vector M and N only, you can see that from S to Q, you can use either SP plus PQ, or you can use SR plus RQ in order to find SQ. So let's say I want to use SP plus PQ. So SQ is vector SP plus vector PQ. As we know, vector PS is N. Therefore, vector SP will be negative N, since this is negative vector. So PS goes upward, but SP goes downward. If we have different direction, you must put the negative sign in front of the vector. So SP is negative n. And we already know that PQ is m. So final answer is vector m minus vector n. And note that, as you can see, this is vector SQ. And to get SQ, we do SP plus PQ. So if we cancel out P from the middle part, you'll just be left with SQ only. So that is one way of knowing whether this is correct or not. Next, we have PR. So PR is here. And to get PR, is either PQ plus QR or maybe PS plus SR. So let's say I want to do vector PS plus vector SR. So I know that vector PS is n and vector SR is m. And that's our final answer for vector PR. And lastly, we have vector PT, which is this one. So to get vector PT, you can use either PS plus ST or PQ plus QR plus QT. So it's much easier to use the first one. So we know that vector PS is n. But what about ST? Right here. So note that vector ST right here is actually half times vector SR. So this is SR and ST is exactly half of it. That's why we can write it like this. And we already know that vector SR is m. Therefore, ST is actually half times vector m, which is this one. And that's our final answer for PT.